A signal is repeating from deep space, not random, not chaotic, structured, precise, and getting stronger. Astronomers first thought it was noise, background radiation, another meaningless whisper from the universe, but this signal did not fade. It came back again and again, each time with a pattern that should not exist in nature. That is where the problem begins. The more scientists study it, the less it makes sense. It does not behave like a star. It does not behave like a black hole. It does not match any known cosmic event. It follows rules, but not the rules we understand. And here is the part that makes it even stranger. We are getting better at detecting it. Our instruments are improving. Our reach into deep space is expanding. And as that happens, these signals are no longer rare. They are becoming more frequent, more detailed, more impossible to ignore. Something out there is not just sending energy, it is doing it in a way that forces attention. Space was never truly silent. That idea was always a myth. The universe is filled with noise. Invisible waves travel through it every second. Radio signals, gamma rays, X-rays, bursts of energy from violent cosmic events, colliding stars, exploding supernovas, feeding black holes. All of it creates a constant background of activity. For decades, scientists believed most of this could be explained. Each signal had a source. Each pattern had a cause. Even the most powerful events could be traced back to known physics. But that confidence is starting to crack, because now we are seeing signals that do not follow the expected rules. Some appear for a fraction of a second, then vanish forever. Others repeat with strange timing. Some carry more energy than entire galaxies produce in short bursts. And a few behave in ways that suggest structure, not chaos. That is not something the universe usually does. Natural events are messy. Explosions scatter energy in unpredictable ways. Collisions create turbulence. Even the most powerful forces in space follow patterns that can be modeled and predicted, but these signals break that expectation. They are too clean, too focused, too consistent, and the deeper scientists look, the more unsettling the data becomes. In recent years, advanced telescopes have begun scanning the sky with extreme sensitivity. They are not just observing stars and planets. They are listening, searching for any unusual activity across vast distances, and what they are finding is forcing a new kind of question. Not where does it come from, but why does it look like this? Because some of these signals repeat in cycles. Exact cycles, not random intervals, not chaotic bursts. Precise timing that continues over long periods. That kind of behavior is extremely rare in natural systems. There are theories, there are always theories. Some scientists point to magnetars. These are ultra-dense neutron stars with magnetic fields so strong they can tear atoms apart. They can release massive bursts of energy. In some cases, they can create repeating signals. But even magnetars do not explain everything. The energy levels are sometimes too high, the patterns too regular, the distances too extreme. Others explain X and stay involved black holes, regions of space where gravity is so intense that nothing can escape, not even light. Black holes can produce powerful jets of energy. They can distort space and time. They can create strange signals. But again, something does not fully match because black holes are chaotic, violent, unpredictable. These signals are not. There's also another detail that most people never hear about. Some of these signals travel through regions of space that should distort them, clouds of gas, magnetic fields, gravitational interference. All of these should scramble the signal, but in certain cases, the signal arrives almost perfectly intact. That suggests something unusual about how it was created or how it traveled. And that leads to a deeper mystery. Because if the universe is capable of producing something like this, then our understanding of physics is incomplete. There are processes happening out there that we do not yet understand. This is not about proving anything. It is not about jumping to conclusions. It is about facing a simple fact. There are signals in deep space that we cannot explain, not yet, and every year we are finding more of them. The tools we use to study the universe are becoming more powerful. New observatories are scanning the sky day and night. Artificial intelligence is helping detect patterns that humans would miss. Massive arrays of radio telescopes are working together to listen deeper into space than ever before. And as this happens, the number of unexplained signals is growing, not shrinking. That is the opposite of what science expects. Normally, more data leads to more answers, more clarity, more understanding. But here, more data is creating more questions, stronger questions, because now it is no longer about a single strange signal. It is about a pattern of anomalies, a growing list of events that do not fit into any known category, and that changes everything. Because it means we are not just missing one explanation, we might be missing an entire piece of how the universe works. In this video, you are going to learn what these signals are, where they are coming from, and why they are so difficult to explain. You will see how scientists are trying to decode them, what theories exist, and where those theories fail. You will also discover the lesser-known details, the parts that rarely get discussed, the data points that do not make headlines, but quietly challenge everything we thought we knew about deep space. And by the end, you will understand why this is not just another space mystery. This could be one of the most important discoveries of our time, because something out there is sending signals. They are repeating. They are structured, and we are finally starting to notice. Welcome to the channel. Subscribe now, because the deeper we go into space, the stranger it becomes. The discovery did not begin with something dramatic. It started as a faint signal buried in noise. A brief flash of radio energy picked up by a telescope scanning the sky. It lasted only milliseconds, then it disappeared. At first, no one paid much attention. Space is full of random signals. Most of them come from natural sources. Pulsars spin and emit regular pulses. Stars flare and release bursts of radiation. Galaxies hum with background noise that fills the universe. But this signal was different, did not look chaotic. It looked clean, focused, almost too precise. When scientists checked the data, they assumed it was interference. Signals from Earth often leak into observations. Signals from Earth often leak into observations. Satellites, radar systems, even microwave ovens have contaminated readings before. There have been cases where entire research teams chased signals for months, only to discover the source was a machine on Earth. So they filtered it out, but then it came back. Same type of signal, same strange structure, again lasting only a fraction of a second. Then silence. That was when things started to shift. More telescopes began to detect similar signals. Not identical, but close enough to raise concern. Some appeared once and never returned. Others repeated, not randomly, but in intervals that hinted at a pattern. This is where the mystery deepened. Natural cosmic events are messy. Explosions scatter energy in all directions. Collisions create turbulence. Even pulsars, which are known for their regular signals, showed small variations over time. But these signals showed something else, consistency. Some repeated with gaps that followed a rhythm, not perfect, but not random either. Others stayed silent for long periods, then suddenly became active again. It was as if something turned them on and off. That behavior does not match most known astrophysical sources. There is another detail that made scientists uneasy. The signals carried enormous energy. In a single millisecond, some of them released as much energy as the sun produces in several days. That kind of power requires extreme conditions. Only the most violent objects in the universe can produce it. But those objects leave signatures, clear signs of their presence. These signals did not. They came from distant regions of space, billions of light years away. That means they started their journey long before Earth even formed complex life. They traveled across the universe through clouds of gas and magnetic fields and still arrived sharp and detectable. That should not happen so cleanly. In some cases, the signals also showed something called dispersion. This is when different frequencies arrive at slightly different times due to traveling through space. Scientists use this to estimate distance, and the results were shocking. These signals were coming from far outside our galaxy, not from nearby stars, not from known objects in the Milky Way, but from deep, distant regions where very little is understood. At that scale, even small anomalies become significant. Some signals also showed polarization. This means their waves were aligned in a specific way that usually happens when strong magnetic fields are involved, but the level of polarization seen in certain signals suggests environments far more extreme than expected. It points to conditions that push the limits of known physics. At first, researchers tried to fit these signals into existing models, pulsars, magnetars, black hole activity. Each theory explained part of the data, but never all of it. There was always something missing, a pattern that did not fit, a detail that broke the model. And the more data they collected, the more those gaps grew. Instead of becoming clearer, the picture became more complicated. Signals that repeat, but not perfectly. Signals that appear once and never return, signals that carry immense energy, yet show unusual precision. It is a combination that should not exist so frequently, and yet it does. The signals are not the only mystery. Something else has been detected. Not a sound, not radiation, something physical, something moving. Astronomers have been tracking objects in deep space for decades. Most follow predictable paths. Gravity controls everything. Stars pull on planets. Galaxies shape the motion of entire systems. Even objects traveling between stars still obeyed these rules. But recently, a few objects broke that pattern. They appeared suddenly. No warning, no clear origin, moving at speeds that did not match anything bound to our sun, and more importantly, their paths did not make sense. One of the first known cases came from an object that entered our solar system from deep space. It was not orbiting the sun. It was passing through, a visitor, fast, silent, and on a trajectory that suggested it came from far beyond our local region of the galaxy. At first it looked like a comet. That is a normal assumption. Comets can travel long distances. They release gas as they approach the sun, creating a visible tail, but this object did not behave like a normal comet. There was no clear tail, no visible gas cloud, yet it was accelerating slightly as it moved away from the sun. That should not happen without some kind of force pushing it. Gravity alone could not explain it. Scientists looked closer. They measured its speed, its path, its brightness. The shape appeared unusual, long, possibly flat or elongated, not round like most asteroids. Then came the strangest part. It changed its motion in a subtle way. Not a sharp turn, not a sudden shift, a small but measurable deviation, enough to raise serious questions. One explanation suggested that it was releasing gas in a way that was hard to detect. Another idea proposed that radiation pressure from sunlight was pushing it like a sail, but both explanations had problems. The gas should have been visible. The push from sunlight should not have been strong enough unless the object had an extremely unusual structure. And then it was gone. It left the solar system as quickly as it entered. No second chance to study it. No way to confirm what it truly was. Since then, more interstellar objects have been detected. Each one adds a new layer to the mystery. Some move too fast. Others follow paths that seem slightly off from what gravity predicts. Most still fit within natural explanations, but not perfectly. There is always a small detail that does not align, and those small details matter. Because space is predictable on large scales, the laws of motion are well understood. When something deviates, even slightly, it suggests either a hidden factor or a gap in understanding. There are also observations of stars and gas clouds behaving in unexpected ways in distant regions of space. Motions that seem influenced by something unseen, not just dark matter, which is already part of current models, but something more complex. Some regions show coordinated motion, objects move in ways that hint at an underlying structure or force that has not been identified. It is subtle, easy to overlook, but consistent enough to be studied. And when these strange motions are considered alongside the signals, a question begins to form, not just about what is sending the signals, but about what else might be out there, moving through space, crossing distances between stars, following paths that do not fully match the rules that govern everything else, something that enters, shifts, and leaves before it can be understood. And each time one of these objects appears, it brings the same pattern. unexpected speed, unusual trajectory, and just enough mystery to keep scientists searching for answers that still feel out of reach. The universe is built on motion. Every planet, every star, every galaxy follows paths shaped by gravity. These paths can be calculated with extreme precision. Scientists can predict where an object will be years into the future using equations that rarely fail. That is why the anomalies stand out. Because some objects are not following the script, they appear suddenly in telescope data, faint at first, then clearer, moving fast, too fast to belong to our solar system. Their paths cut across the usual flow of objects that orbit the sun. They are not bound to it. They're just passing through. Interstellar visitors, that alone is rare. For a long time, none had ever been confirmed. Then one was detected moving through our system at high speed. It came from outside. It did not slow down. It did not stay. It was already leaving. Its path was traced backward. It did not originate from any known nearby star. It came from deep space, a region so distant that its journey must have taken millions, possibly billions of years. But the real mystery was not where it came from. It was how it moved. As it passed the sun, it showed a slight axillary, ration, not large, not dramatic, but enough to be measured, enough to break expectations. Gravity should have been the only force acting on it at that distance. Yet something gave it an extra push. Scientists searched for a cause. Scientists searched for a cause. The most accepted idea involved outgassing. Comets release gas when heated by the sun, creating a small thrust. That can change motion slightly, but there was a problem. No visible gas was detected, no tail, no surrounding cloud, nothing that clearly explained the acceleration. This detail became a point of tension because it meant either the gas was somehow invisible or something else was happening. The shape of the object added to the confusion. Observation suggested it was not spherical. It seemed elongated, possibly flat. Its brightness changed rapidly as it rotated, hinting at an unusual structure. That kind of shape is not common for natural space debris. Then came another object, different in appearance, but still from interstellar space. This one behaved more like a comet with visible gas and dust, yet its speed and trajectory were still extreme. It entered fast, then left even faster as if it had no interest in staying. Each new detection brings more data, but also more uncertainty, because these objects do not arrive in predictable ways. There is no warning. They are only noticed once they are already inside the solar system, already moving at high velocity. By the time scientists focus their instruments, the window is closing. And then there are the smaller anomalies, tiny deviations in motion observed in distant regions, gas clouds shifting in ways that do not fully match gravitational models, stars showing slight irregularities in their paths, nothing large enough to rewrite physics on its own, but enough to raise questions when seen together. Some researchers suggest hidden influences, unknown distributions of matter. Subtle interactions that are not yet understood. Others consider more complex forces at play, effects that only become visible under extreme conditions. There is also the possibility that these objects are shaped by environments far more violent than anything near our solar system, regions where magnetic fields twist space, where gravity interacts with matter in ways that are still being studied. That could explain part of the motion, but not all of it, because a pattern remains. Objects that arrive from the dark between stars, moving faster than expected, following paths that feel slightly off, showing behavior that almost fits known physics but never perfectly. And each time one is detected, it raises the same quiet question. Is this just the edge of what we understand or the beginning of something entirely different moving through the universe unnoticed? Scientists do not jump to extreme conclusions. They start with what is known. They test every signal against the laws of physics that have worked for decades, and at first the explanation seems solid. Neutron stars are one of the first candidates. These are the collapsed cores of massive stars. They're incredibly dense. A single teaspoon of their material would weigh billions of tons. When they spin, they can emit beams of radiation like a lighthouse. That creates regular pulses that can be detected from Earth. Some of the repeating signals look similar to this behavior and come magnetars. These are even more extreme. A type of neutron star with magnetic fields so powerful they can distort atoms. When magnetars release energy, the burst can be intense and sudden. In recent years, at least one fast radio burst has been linked to a magnetar inside our own galaxy. That was a major breakthrough. It proved that at least some of these mysterious signals can come from known objects, but it did not solve the entity. Mystery, because many signals still do not match what magnetars produce. The energy levels can be too high, the patterns too stable, the repetition too precise over long periods. Black holes are also considered. These objects dominate their surroundings. They pull in matter and release powerful jets of energy. In some cases, those jets can create detectable signals across vast distances, but black holes are chaotic systems. The signals linked to them usually show turbulence, variation, noise. The signals being studied sometimes show the opposite order. That is where the tension grows. Each known explanation fits part of the data. None of them fit all of it. There is always a mismatch, a detail that refuses to align. This is where more unusual ideas begin to appear. Some scientists suggest that there may be unknown types of stellar objects, variations of neutron stars or exotic remnants that behave differently under extreme conditions. Others consider the role of plasma structures in deep space, clouds of charged particles that could, under certain conditions, create focused bursts of energy. There are also theories involving new physics, not a small adjustment, something deeper. New forms of matter, new interactions that only become visible at massive scales or extreme energies. These ideas are difficult to test. They require conditions that cannot be recreated on Earth. Then there's a more controversial line of thought. The possibility that some signals may not be purely natural. This idea is treated with caution. Scientists avoid it unless all other explanations fail. There is no confirmed evidence for intelligent origin, no verified pattern that clearly points to design, but the discussion exists quietly because certain signals show levels of structure that are difficult to ignore, not proof, not even close, but enough to keep the question alive in the bath. E-card crowns, even those who consider this possibility, often return to natural explanations. The universe is vast. It can produce events that seem unnatural simply because they are rare or not yet understood. That remains the most grounded position. Still, uncertainty is growing. More data is coming in, more signals are being detected, and instead of narrowing the answers, the range of possibilities is expanding. The known explanations are being stretched to their limits. And beyond those limits, there is only theory. For a long time, science moved in one direction. More data meant more answers. Each discovery filled a gap. Each new observation made the universe feel more complete. The laws of physics held strong across every scale we could test. But now something is shifting. These signals and strange objects are not just isolated mysteries. They are cracks in a system that once felt stable. Small cracks, but growing. And they appear in places where our understanding should be strongest, because the physics that explains stars, galaxies, and motion through space has been tested again and again. It predicts behavior with incredible accuracy. It allowed humans to send spacecraft across the solar system and land them with precision. So when something does not fit, it matters. These anomalies are not random errors. They repeat, they persist. They appear across different observations and different instruments. That removes the simplest explanation, which is mistake. And when mistakes are removed, only two options remain. Either the explanation is incomplete, or the understanding itself is some of these signals carry more energy than expected from known sources. That alone pushes the limits of current models. Energy must come from somewhere. Misfollow rules. If those rules do not explain what is observed, then either the source is unknown or the rules need to change. That idea is not new in science. In the past, similar gaps led to major breakthroughs. The motion of planets once seemed slightly off. That led to new theories of gravity. The behavior of light did not match classical physics. That led to quantum mechanics. Each time, the universe forced a correction. This could be another moment like that, because now, the deeper we look into space, the less predictable it becomes. That is the opposite of what should happen. Better technology should reduce uncertainty. It should sharpen the image, clarify the signal, remove noise. Instead, it is revealing complexity, hidden patterns, unusual behavior, events that do not fit into clean categories. There's also a scale problem. Most of these anomalies occur at extreme distances, billions of light years away. That means we are seeing events as they happened in the distant past, early in the history of the universe. If something unusual was more common back then, it could mean the universe itself behaved differently in its earlier stages. That would have massive implications. It would mean that the rules we observe today are not the full story. They are just the current state of something that has evolved over time. There are also hints that space itself may not be as uniform as once believed. Certain regions show unexpected behavior, variations that suggest hidden structures or influences, not visible but detectable through their effects. That raises a deeper concern. If space is not fully understood, then everything inside it becomes harder to interpret. Distance, energy, motion, all depend on the properties of space itself. And if those properties are not constant, then even basic assumptions can shift. This is why these discoveries matter beyond curiosity. They touch the foundation of physics. They force scientists to question results that once felt certain, to revisit models that seemed complete, to consider possibilities that were once dismissed. And perhaps the most unsettling part is this: the more we search for answers, the more questions appear. Each signal decoded leads to new unknowns. Each object tracked reveals new anomalies. Each theory tested opens new gaps. Progress is still happening. Data is still being collected. Understanding is still growing, but it is not closing the mystery, it is expanding it. Something in deep space is still unexplained, not proven to be alive, not proven to be artificial, but also not fully understood. The signals continue to arrive, short, powerful, precise. Some repeat, some vanish forever. Each one adds another piece to a puzzle that still has no clear picture. The objects keep moving through the dark, entering, leaving, following paths that feel just slightly off, enough to question what is really guiding them. The theories try to keep up: neutron stars, magnetars, black holes. All of them explain parts of the story. None of them explain all of it. And that is the point that matters, because this is no longer about one strange signal or one unusual object. This is a pattern, a growing list of mysteries that refuse to fit into what we already know. Science is not failing here. It is being pushed, forced to expand, forced to face the limits of its current understanding. And that is where the real story begins. Every time we build better tools, we see deeper into space, and every time we see deeper, the universe becomes more complex, not less. That means something is still hidden, not far away in distance, but just beyond our understanding. Key signals are still coming. The anomalies are still there. Quiet, distant, but persistent. And with every new discovery, we move one step closer to an answer, or closer to a question that changes everything. If you found this journey into the unknown interesting, support the channel by liking the video and subscribing. There is much more to uncover, and the next discovery could change how we see the universe forever. Because out there, in the deep silence of space, something is still waiting.